This is an example which is similar to the previous example we already taken up. Here also there are 12 resistances which are connected in a cube-like fashion, and now we are required to find the equivalent resistance across the terminals A and B in the circuit, and again each resistance is of value R. Then to calculate across the terminals, we connect a battery of 100 volts. And if we connect the 100 volt battery here, we can take on the negative terminal potential as 0 volt, and on the positive side it is say 100 volt. And if a current I is flowing through the circuit, then we can directly write the value of equivalent resistance to be equals to 100 divided by I. Now in this equation, the current here is divided in 3 branches of the circuit, out of which one branch is directly connected to the zero potential, where current we can write say as I1, which is already known, that is 100 minus 0 by R. And these two paths with respect to terminal B and A are identical, so currents here will be same, say these are I2 and I2. And similarly, as the way current is distributed, it will recombine at the end B. So here also the current will be I2 and I2. So in this situation we can say the potential at point C and F must be equal, because as these two resistances are equal, we can say here if potential is X, here also it can be taken as X. And if here potential is 100 at point D and E, as the two currents are equal, potential difference across these resistances are equal, it can be taken as 100 minus X and 100 minus X. Now further, if we talk about the distribution of this current I2 into two parts, say this will be I3 and I4. Here also at the time of recombination, this I4, this current will be I3. So we can say if potential at point G is taken as Y, at point H we can take as 100 minus Y, because the difference of potential of G with the end B must be exactly equal to the difference of potential of point H with end A, because the circuit is perfectly symmetrical. Now we just need to calculate the value of X, using which we can get the value of I2, I1 we already know, we can substitute here. As in this situation, the value of equivalent resistance we can write as 100 by I, which is I1 plus 2I2. And I2 we can calculate on the basis of X. So in solution, here we can write KCL equation for X. So if we write KCL equation for X, it is connected with the 3 branches each of resistance R. So in this situation we can write the current, outgoing current in this direction will be X minus 0 by R, plus in this direction it will be X minus Y by R, plus in this direction will be X minus of 100 minus X by R is equals to 0. Here R gets cancelled out, and on solving we are getting an equation 4X minus Y is equals to 100. This is here equation 1. Now we need to substitute the value of Y, then only we can get the value of X. So we need to write another KCL equation, that is for the potential Y. So the junction G where potential we have taken as Y, if we write down the KCL equation for all the 3 branches, outgoing currents is equals to 0. Here you can see in this direction it will be Y minus X by R, plus in this direction again it is Y minus X by R, plus in this direction it will be Y minus of 100 minus Y by R is equals to 0. Here R gets cancelled out, and on simplifying we are getting the equation 4Y minus 2X is equals to 100. That is our second equation. Now to calculate the value of X, we need to eliminate Y from these equations. So we can multiply this equation 1 by 4, and we can add these two equations. And you can see 4 into 4 is 16 minus 2. This will be 14X. And Y gets cancelled out and is equals to 400 plus 100. This will be 500. This implies the value of X we are getting is 250 by 7 volt. Now Here if we substitute the values of I1 and I2, this R equivalent we can write as 100 divided by I1 we can write directly by Ohm's law, this 100 minus 0 by R, that will be 100 by R, plus I2 we can write as X minus 0 by R, so it is 2I2, so this will be twice of X by R, which can be written as 250 by 7R. So in this situation it will be 500 by 7, we can take this R common. So here we are getting the final result to be 700 R divided by, here it will be 700 plus 500, it is 1200. So the final equivalent resistance across terminals A and B we are getting is 7 by 12 R. That is the answer to this problem.